welcome back. Today we continue our. Today we have a new video in Leetcode. We have a medium problem called swap nodes in pair. Problem number 24. Problem has been asked by. It's one you ask not quite often, but it has some consistency to it. The problem says that given a linked list, swap every two adjacent nodes and return its head. You must solve the problem without modifying the values in the list's node. Only nodes themselves may be changed. Okay. So we have this example and we swap every two. So one will be we swap it with two. So with 2, 1 and 3 with 4, we have 4, 3. So it's a quite straightforward, it's quite easy. And I don't know why this problem is medium, because in my opinion, the problem will be easy problems, not medium. There's two ways to solve this problem. We can do it in a recursive way, or we can do just iteration to solve it. And I'm thinking that we could do it in this video. We try to do it in recursive way. So, the way that we do it, that we try to call, like we swap once, and we try to call it until we find no head, until we find no next or no head. So let's just try to find. First, we have the head here. Okay. So what we do, because we make this function is a recursive function, we should try to find the base case. So the base case, in my opinion, it will be when we can't find a head, or when we can't find the head next. So there is no current head, or there is no element to swap with. So in this one, I will just return head. And next, I will just I will try to find the nodes that I will swap. So first, I will have var first, which will be the head, and after that, I will try for the second, which will be the head not next. So I have the two nodes that I will swap each other with them. And first, what I will do, because this might look quite tough, I will say like the first dot next will equals whatever comes from this, will equals whatever comes with this function, and I will put the second dot next to try to swap for the future things. And the second dot next will equals first, and after that I will return the second. Okay, what's going on? I guess some of you don't understand anything. It doesn't look quite easier to understand, so let's just try to break it. So first we check the head of the linked list. If it's null, or there is no, or there is only one node left, we in this such a case, we cannot swap, so we return the head. After that, we create two variables, first and second, to represent the nodes that we will be swap. Okay, after that, we perform the swap operation. So the next pointer of the first to the result swapping the remaining nodes. So I guess this will be the toughest one to understand, this line. So what we're doing here, it's basically let's just try to say one by one. So here in this one, we set the next pointer. We get the value of the next pointer, okay, to the result of the swapping the remaining nodes. So let's just try to make it easier. Maybe it's not that even. So we have first dot next. This part access the next property of the first node. Okay, in the current pair nodes, initially the first node represents the first node of the pair that we want to swap. Okay, we have the swap pairs. This function that we call again the swap pairs. dot next, the second node dot next, because we said the first dot next will equals the second dot next. So here, this part of the line calls the swap pairs function recursively with second dot next as its argument. So let's just try to think about this one. So the second node represents the second the second node represent the second node of the current pair, and the second dot next is the node of the the second the next is that is the node that follows its original in the original list. So the second next is the third one. So for example, this is the first, this is the second, this is second next. Okay, this is first, this is second, this is second next. Okay, so inside the recursive call, the function will continue swapping the continue swapping pairs of nodes in the remaining portion of the list, starting from second.next, which will be this one, and it will eventually return the head of the modified sublist after the all swaps. And after in this line, after first node.next, first.next, this assignment is crucial for swapping process. It updates the next reference of the first node. Okay, it's quite important to understand this one. So this one, we try to update the next reference of the first node to point to the result of swapping the remaining nodes. As a result, the first node in the current pair become the new second node after the swap, while reversing the order of the nodes in the rest of the list. And the second, because next to the first, it's just the thing. I guess this will be the one toughest to understand. I guess if we do, yeah, it works and it's not bad. Not editorial. Go to description again, please. So by recursively applying this swapping logic, the function gradually swaps pairs of adjacent nodes. So this is the way that we solve it. It's 5-6 lines, but it's really not that easy to understand. So we have the two nodes that we want to swap. We want to make sure that we have the first name, and we call the function again to make sure that we swap the next elements. And we have the second next, which will be this one, which will be equals whatever we have in the first without swapping at all. And after that, we return the second. So basically, we return the second because we swap everything, so it will be 2. And because the second next will equals first, so second next will equals 4, so it will be 1. And when we try to do this for each one, it will work like that. So that's it for this video, and I hope my description was quite good. If you like my content, make sure to subscribe and hit the notification bell so you never miss a video, and see you in future problems.